Good morning, everyone. My name is Joachim, and I work at Know-How Solution in Sweden. Today, I'm very happy to welcome you to this webinar, how you can de-risk your supply chain by detecting security vulnerabilities. I work in Sweden, and my colleague Henrik and Marco is the contacts for Denmark and Finland. And today I have also Alan and Rob from GrammaTech UK. So welcome, Alan and Rob. You will speak a little bit today. So, but before that, I will just do some housekeeping information. So we start, I will show a slide about know-how, so you know what that is. And Alan will talk a little bit about GrammaTech. And Alan will continue, will continue with I need to mute someone here. Sorry for that. And then Rob will show a demo of the solution CodeSentry. And this, of course, will be recorded, and you will get a recording, a link to the recording afterwards. So I just want to show know-how. Know-how solution in Sweden is turning 40 years old this autumn. And we are working with customers mainly developing embedded software or product with embedded software inside. So we have partnership with a couple of vendors. So some solutions are very close to the embedded developer, that is Lauterbach debuggers, compilers from ARM, Tasking, Seger, and so on. Then we have also a partnership with Gramatec, that we're going to talk about today. This tool in this box is a little bit more analysis tool, quality tools, static analysis for security vulnerabilities, LaTeX for architecture analysis, QA system. They are making a tool called Cantata that is a unit testing tool, and Danlaw is more a system testing tool. We have also components for communications like CAN interface. We have frontline analysis for Bluetooth, Wi-Fi, USB, and so on. And we have analysis tool for Achilles testing from Vertec. And we have some also software components like Artus and security solutions from Cisco and Icon Labs. And we also work with more ALM suppliers like Visure, IBM, and Micro Focus. So by saying that, I will hand over to you, Alan. You will start to.
That's great. Thank you.
Yeah, I will switch.
I'll wait for the icon to appear.
Yeah. Oh, hopefully.
There we go. Good. Excellent.
Thank you.
Got it. So you'll see some interesting wallpaper, hopefully, and then we'll get the slideshow underway. So if you can let me know, hopefully you can see a big Gramatec logo on the screen. So thank you very much to everyone at Know-How really for inviting us today to present what is a relatively new technology stack for us in the binary software composition analysis area. For those of you who don't know us, at Gramatec, the headquarters of Gramatec is in Bethesda, Maryland. There's an R&D facility in Ithaca, which is very close to Cornell University, where a lot of the PhDs fall out of Cornell and into Gramatec, I think. We've been established as an application security testing vendor and cybersecurity research vendor really for a number of years. You can see a lot of the cybersecurity research, which was the genesis of Gramatec, started something like 30 years ago. A lot of DoD contracts, doing a lot of work now in artificial intelligence, machine learning, focused on the cybersecurity space. And some of those interesting research technologies have found their way into products. So we have two products on the market, CodeSentry, which is a static analysis tool for C, C++, C#, Java, and binary analysis. And as I said, the recently launched CodeSentry tool that we're going to talk a little bit about today. So lots of things going on with CodeSentry. Rob and I joined GrammaTech relatively recently to establish the UK office. So our role is very much supporting our distribution channel. So companies like Know How. We also have some direct sales, for example, in UK, Ireland, and so on that we look after as well. So what's this all about? Well, this is could probably update these slides every day. I could probably look in the last few minutes and update the slides. That there's always publicity effectively that's going on to say, hey, there's some sort of vulnerability that's been uncovered in some software. So whether it be Zoom or Adobe or Exchange or SolarWinds or whatever it happens to be, there are clearly vulnerabilities that exist out there. And a lot of that focus in terms of the press is clearly on desktop software, but it's just as important in the embedded space. And so there are a couple of different areas in which we can apply this that we'll talk about as we go through the presentation. So there are quite a few software component analysis tools on the market, most of them focused on source code. So if you have the source code available, you could run some sort of analysis and it will tell you potential vulnerabilities, CVEs within the application. The challenge for an awful lot of organizations, though, is you don't get delivered your applications with the source code. So if you're deploying, I don't know, Google Chrome on the desktop in a large bank, for example, you don't get the source code for Google Chrome. You don't get the source code for your particular applications. You need to make some sort of judgment as to whether this application is secure. Similarly, if you're using free and open source software or you're building in third-party binary libraries into an embedded application, you may not necessarily always have access to all of the source code and know what's being included in the applications that you're building. So it's a bit of a challenge, really, for organizations to know what it is they're actually including into their software. So you may get a software bill of materials from your vendor to say, in our software, we have these components, we have these known vulnerabilities, but do they actually know themselves what it is they're building in to their application? So part of the challenge is, can you trust the vendor? Have you got ways of verifying what that vendor's actually delivering to you? The trouble with binary applications is clearly it's quite difficult to detect those components. You're dealing with almost a black box. How do you find out whether you've got some sort of TCP/IP or Bluetooth component within there, and how do you know whether that's got vulnerabilities? So you might do some penetration testing. You might get people to look more deeply into the binary. They're kind of difficult people to find. And certainly for desktop applications, we're hearing stories that it can take sort of months for a new application that's been delivered to be deployed into the business. And then there's the problem of efficacy. How do you know what you're going to do with that vulnerability? What did you find? How are you going to fix that vulnerability? So CodeSentry is purely focused on binary software composition analysis. The initial work was funded by the US Department of Defense. And what we're looking to do with CodeSentry is identify open source components with known vulnerabilities within them. those end-day vulnerabilities and CVEs are a major threat, clearly. And what we're looking to do as well is then say, can we, once we've scanned an application, if a new identified vulnerability is published, we can look back and say, okay, we scanned that 6 months ago. There's a new vulnerability. We need to basically alert people that there's an issue. So that might be internally that we're alerting, but it could just as easily be that we're creating a software bill of materials that we're shipping to our customers with product that we're delivering, be that desktop software or some sort of embedded component. We can deliver CodeSentry as an on-premise solution, or more typically what we're looking to is a software as a service hosted in the cloud. So you literally upload a binary, do the scan, it will report back, and you can dig into the results. So how are we doing that? Well, there's a lot of scans that have been done on different components from different repositories. That's given us effectively some semantic signatures, and then what we're looking to do is match those against the binaries that have been uploaded to look into those to see whether we can detect those and with what sort of confidence can we do it. So one of the real values here is we've got, we think, very high recall and very good precision on the results. So less false negatives, less false positives, and a good rate of detection and a confidence level that tells you whether the tool believes, at least with its matching, that you've actually got those components existing within the tools. So the way we're doing our scans provides compiler independence. We're compiling the components with lots of different compilers with lots of different flags and switches set. So we've got some good ways then with the machine learning of uncovering those defects. So it's a relatively simple process. You take your application under test, load into CodeSentry and ingest that binary. We match against the components, and then we can produce a software bill of materials and a list of the vulnerabilities that exist against a known components database. It's also possible, we have the ability to do a private components database where you can curate your own database rather than the database that we're curating, the public database that we're curating. And we store those applications basically in a cache for later analysis. So there are two primary matching algorithms, I guess. One that's focused very much on fast feedback that we call a shallow scan that can return the results in a matter of minutes. And then there's a deeper detection that we can apply where we're really looking at the control flow. So we might do things that are focused on bytes and strings and symbols within the binary. We can also look at that control flow. So you can think of it really in terms of a disassembly of that code, so that we can effectively get a much deeper signature to match against. So from a UI point of view, and you'll see this in the demo, when we launch a new scan, literally we define a project, we define the application. So that might be a particular version of an application. Select the scan depth, drop the file on the interface, and then effectively the results come back, and we'll look in more detail on this as we go through. Again, we also produce a bill of materials, so you know exactly what you've got in your software, and you can provide that if needs be to customers and partners alike. So where do we get that information? Effectively, we're getting that from the National Vulnerability database. So we get a list of CVEs, and we get their CVSS scores. Ultimately, we'll be able to get information about the licenses and the list of functions that are included in the application. So one of the challenges is clearly for people that are building these applications is, and I think it's quite a telling thing, that the vulnerability may well be notified, and at a certain point in time. But one of the challenges is that a huge number of those do not get patched and do not get dealt with. Now, clearly, that's relatively more straightforward in a desktop type application. It can get a little more challenging, clearly, in the embedded application, where maybe it's a little bit more difficult to go and flash something or actually update those applications. So from an architectural point of view, this is built very much as a modern architecture. Everything is accessible through GraphQL API, and that indeed is how we produce our user interface and dashboards and reporting and so on. But that's actually available as well to end users. So if you've got your own systems that you want to integrate with, again, that's a very straightforward process. So today we're released the NDA service, where we're looking at known vulnerabilities and CVEs. We've also got the ability to look at plugging in some of our binary analysis capability, the analyzers from CodeSentry, that have been effectively tuned for this sort of task as a 0-day service. And obviously then the ability to do that with your own private databases. So three primary use cases. We've talked a little bit about COTS from the perspective of your supply chain. You're buying these things in, you're deploying them within your infrastructure. I was talking to an ex-CISO of a bank the other day, and we were talking about the fact that you might get these applications delivered. Your supplier and your vendor is telling you there are certain vulnerabilities that exist within them, and there's a level of trust there. Certainly, if it's a well-known vendor, high volume, you've got strong relationships with, you buy a lot of their software, and you're buying sort of millions of dollars of software from them, then you may be more comfortable than those where you've just got a few licenses. And you could think in terms of legally enforcing, for example, that the software you're going to ship us is essentially free of defects according to the SBOM that you've delivered. His point was, though, you should really be doing some internal work to try and validate that, because if you end up in the courts, it can take years. You've still got the issue that actually your brand has suffered, you've been compromised, and you've got to basically undo the issues that you've seen. So, COTS is one area we certainly see CodeSentry being used for. It may well be that you're procuring software that's custom built, and there's some application development there for internal and external use. People are supplying you with built applications. But increasingly, we're seeing in terms of product development where a developer may be picking up and using part of an open source repository for a particular functionality, and then that's getting built into the embedded applications that they're building, or the desktop applications that they're building. So we see a lot of use within the embedded space, particularly in automotive, IoT, and the industry sectors that you can see on the screen. So I guess before we get to demo, quick takeaway message is, software component analysis and composition analysis has typically been focused on source code. It isn't anymore. We can see use cases in pretty much every vertical that we've dealt with. And certainly we see open source vulnerabilities in pretty much any application that we've thrown at CodeSentry. So they're in internal applications as well as commercial off-the-shelf software. I think certainly the first demo I was involved with, the customer or prospect we were talking to insisted on using Zoom, so we thought it'd be quite nice to do a demo where we showed CodeSentry analyzing Zoom, which was kind of interesting for them. So we think we've got some really good tooling now, both from a static analysis point of view, but also from a software component analysis point of view, to try and uncover and combat these vulnerabilities, even if you haven't got the source code available to you. So I think what I'd like to do is hand over to Rob. So I think I need to stop sharing my screen possibly, which I will endeavour to find the window and stop, and then Joachim can pass over to Rob for a quick demo.
Thanks, Alan. I just switched to Rob here. And I can see your screen, Rob.
Excellent. Thanks, Joachim. Okay. Well, I think Alan did a nice, thorough job there. He made my job quite easy because demonstrating CodeSentry it's pretty straightforward. So as you can see here, I'm connected to one of our instances that's running in the cloud. Again, as Alan said, you can install CodeSentry locally as well. And obviously my presentation is going to be, quite visual. I'm interacting with a web browser, but just to reiterate a point of Alan's again, all of the key functionalities that you're going to see me demonstrate, uploading things to analyze and looking at results, all of that behavior can be controlled from the command line. So it's easy to integrate CodeSentry into your CI/CD pipelines, if for example, if that's what you'd like to do, or automate the use in some way. So this is the landing page for this particular instance here. I'm looking at the summary of existing things that have been uploaded. We've got a whole range of different things here. I can see I've got 13 projects, which are really just these folders. So I've got a Zoom folder and a whatever this is folder, and a Qt5 folder, and Chrome, and so on. And then within all of those folders, I've got 43 applications that have been uploaded for analysis. And of those 43 things that have been uploaded, 28 of them have been, we've detected vulnerabilities that indicate there's some unknown, well, presumably unknown CVEs that were in those things. So how do you upload something? Really straightforward. Click the new scan button. Potentially provide a project name if you want a new one. Provide an application name, the thing of interest that you want to analyze. Choose your scan depth, just 2 settings, shallow and deep. As Ellen said, shallow is sort of a faster analysis, and deep goes that sort of extra mile, including all of the shallow analysis as well, but also looks at the actual logic embedded within the binaries, and then does some various different analyses on that logic as well. And then drop the thing of interest onto this panel here. And it's literally just drag and drop if you're using our UI. It can be individual binaries, executables, DLLs, standalone things basically. Excuse me. But you can also upload other sort of compound objects, if I can call them that, zip files, for example, containing a directory structure which might contain many different executables and DLLs and shared objects and so on. And besides zips, we'll in the very near future be supporting other formats such as MSI files and CAB files, and as you would imagine, a growing list. And then once you've dropped your thing of interest, you're able to start scan, and that's it. Just wait for the scan to complete. So it couldn't be easier to conduct an analysis of the thing of interest. And when you've completed the scan, once the scan has completed, well, you can actually, as the scan is executing, you can get some status information. Obviously, a lot of the scans down here, well, they've all been finished by now, but you can look at the scan status tab for your particular application, and just to see, you know, what's remaining. This was a zip file, and there was a whole range of directories detected in there, and viable targets. So you know, you might upload a zip file which contains non-viable targets such as text files and PDFs and you know, things that aren't binaries of interest. That's fine. They can reside in the zip files. We'll just pick out the things which are relevant to CodeSentry for analysis. So that's the point of the scan status page, to sort of see the progress of what's going. And then once the analysis is finished, the bill of materials and vulnerabilities tab will have some data in them. So obviously we're looking at Zoom here. In this particular case, Zoom was installed, and then its installation directory was zipped up. So that's why, you know, the name here was actually provided as zoom.zip. And then within that zip file, you can see we found a whole range of CVEs that have occurred in a number of libraries or components that we have found are being used by things in that zip file. Okay, so we can see a whole load of libcurls that have been in use, and we've got a high severity. We're sorting this particular vulnerabilities table by severity at the moment. And we can see what the CVE is that has been detected in libcurl, and what version of libcurl we believe was in use as well. And we're very confident for this particular result that libcurl is definitely being used. If we expand the row, we get some additional information. We can see that in this particular case, one of the things which was analysed was this DLL, which was in the original Zoom zip, which we uploaded. And our analysis has detected that this particular DLL uses libcurl, as I say, this particular version. And we can see the evidence for why we believe libcurl is in use by clicking these three, this button here with three dots on it. Well, there's no debug information in that particular case. But if we pick another one, here we see util.dll, and again, we've determined that the free image library version 317 is being used by that. And if we, I'm not having a good hit rate here, am I? But when I come over to the bill of materials tab, we'll definitely see some matches here. So in the bill of materials tab, we're focusing the view rather than by vulnerability, but by target component. And again, we can sort, or we can click on any of these column headers to sort the view by those. At the moment, it's sorted by CVSS distribution, basically the combined score of the detected CVEs in this particular target. And again, we're highly confident that libcurl is being in use by tp.dll, and again, we can drill into the detail information. And in this particular case, we can see it's string-based detail, which we have detected exists within tp.dll, not necessarily exact string matches, because we're using some intelligent analysis even with our string-based comparisons as well. But we've found that versions of these strings do appear in this particular DPL, and having then compared all this string data with our own database library information, we've recognized that these strings also occur in excuse me, libcurl for this particular version of libcurl. So that's why we're highly confident in this case that we've identified a dependency here. And once we're satisfied that we've highlighted and identified correctly a dependency, libcurl, then you can, it's a pretty straightforward task of going through to the CVEs, excuse me, and to review them and to see what, you know, how they're exploited and how critical they are, and for you to then, you know, make your judgments as to whether you're satisfied or not that these are things you can either live with, or, you know, you need to move up to a new version of libcurl if that's, you know, the possibility. Or, you know, if you were analyzing a DLL from one of your suppliers, you know, inform them that it's, you know, an issue that you would like addressing. Further down the list, we can see this another DLL here. In this case, we're confident that it's using the free image library. And if we look at the detail here, excuse me, the 3 dots in this case, we've got a different sort of debug information. So if you remember that the analysis here was done using the deeper analysis, which meant that both the shallow and deep type of analyses would be conducted, whereas the first one that we just looked up in this particular table was predominantly string matching, which had been used to identify and confirm the use of libcurl. In this case, we have been looking at procedural information, which has been used to, you know, known procedures that have been existed that are linked into this particular DLL, and from their names, again with some intelligent matching layered on top of that, we're confident that we're using the free image library. So you can export the results as well. You might need to make presentations to your own customers, for example, about the CVE health of your product, for instance, that you might be selling to them. So we can export the bill of materials either as a PDF or as a CSV file, which you can then, you know, provide along with your software. So as I said, using CodeSentry, it's a quick process, it's a straightforward process, and that's what I have to show you right now. So
could you show the report, the executive report with the bug one? Thank you.
Oh, okay, yeah, of course. Here we go. Okay. Oh, so this is a recently introduced feature. So here's our binary vulnerability scan report. It's telling us that we've had a look at Zoom. We can see some metrics to detail, you know, how sort of vulnerable this particular application is, how many components we identified, our sense of the scan quality that we've conducted. And then we've got the bill of materials listing all of the detected targets, the CVEs that we detected in each of these targets, and the component obviously that was containing these CVEs and the version of the component. And there's a whole long list of CVEs, as you can see, and then we start to break down by component the actual CVEs embedded within each, which are clickable. You can jump through to the links on the National Vulnerability Database's website to get the additional detail and how to reproduce these particular issues.
Thanks, Rob.
Okay, thank you. So questions, please.
Yes, if you have any question, just send it to me in the chat, and I will repeat it. So far, we have not got any question yet. So seems to be crystal clear, Alan.
That's always good to hear. Thank you.
So the first question here is, does the scan work also on statically linked binaries?
I'm going to leave that one for Rob.
Yes, it does. Yes, it does. And you might find yes, it'll detect still that there's elements of those components that are included in those binaries as obviously there has to be, and they'll get reported on as well.
And another question, it's maybe a little bit more difficult because it's can you compare this product to Nessus?
I'm not that familiar with Nessus, but I've come across it a couple of times. I can get back to you, Joachim, and you can pass some information. I just need to do a little bit of digging to give you a high-level comparison on that.
Yeah. So I think we will wait some more. Is there a try and buy option?
Yeah, absolutely. We prefer buy and try, but if you want to do try and buy, that's fine too.
Okay. Yes, you can get an eval on this.
You have to buy, you'll be so impressed.
How about embedded firmware binaries like ARM Core, MCU firmwares?
I think that's fine. I'll let Rob answer that.
Yeah, we're supporting ARM 7 and ARM 8 binaries in addition to Intel binaries at the moment, and it's
But that's only for the deep scan. For the the shallower scans, we don't care about the architectures. But for the deep scan, clearly we're going to do some work we need to understand something about the architecture. So as Rob said, x86, x64, ARM 7, currently ARM 8 very shortly.
Okay, I don't think there are coming any more questions at the moment. So, but if you get questions afterwards, you're always welcome to contact me or Marco or Henrik in Denmark. And Alan, of course, if you want to do that, and we will answer the questions later on. So I just want to thank you for this attendance, and I hope you will visit us next time. And I say thank you to you, Alan, and to you, Rob.
Thank you for inviting us.
Thank you.
Thanks very much.
Thanks a lot. Bye.
Bye-bye.
Bye-bye.